Databases are an integral part of IT landscape of any organization. There are many types of databases. The most common one is the RDBMS or Relational Database Management System, which work on relationships. And then we have document databases, or we have in-memory databases, and then we have NoSQL databases. Then a modern database type is called as graph database. Every database technology has its own use case. For example, for the relational database, you have traditional applications which use tables and they store data into those tables and then access it from there through SQL. Then we have document databases, which are not really general purpose, unlike relational, but they store content management systems backend. They also can store catalogs and user profiles. Then there is in-memory database types, which is used for caching and session management. And then we have graph databases. The graph databases, the graph databases are used to not only store data but also the relationship between the data. Graph databases are useful for solving problems related to connected data. Common use cases include know your customer or KYC, supply chain optimization, predicting drug interaction, and anti-money laundering. The most common use case I have seen of graph databases is in the banks, and banks normally use it for fraud detection and anti-money laundering. Graph databases represent data as nodes and enable organizations to uncover relationship between data that's not possible with other approaches. Now, in this video, I'm going to first give you a quick overview of graph databases, what they are and how you can use them, and then I will be discussing how you can implement the graph database in AWS Cloud. I already have mentioned what what are the different types of the databases, and now let's have a deeper look at graph databases. Graph databases grew out of an area of mathematics called as graph theory and differ from the rest of the databases because in graph databases you put emphasis not just on data but on the relationship between data points. These are graphs not in the sense of pie or bar charts but rather in the mathematical sense of nodes and edges connecting them. Note that edges are sometimes also referred to as relationships. In the picture on your screen, the circles are the nodes, whereas edges are the arrows connecting them. You might think of your data as discrete points or the circles as shown in these diagrams. The value of graph databases stems from storing not just the data but also the relationship between parts of the data. Now, if you look at this photo, you will see that there are two circles or two nodes which are prominent, which are not in the black color. These two nodes primarily are connecting to different graphs. So they could be very important or crucial in this graph relationship. These two nodes have high centrality connecting one side of the graph to another. Now, if you think about a real world case, for instance, just think of a fraud detection. If we build this graph out of a fraud detection in our cloud landscape, where maybe these black circles are virtual machines and these arrows are the traffic flowing between them. Now, if a ransomware or a threat actor takes hold of our network and that threat actor start transferring data from one organization to another, and in this case, for example, the one blue circle on the right hand side represent our organization and on the left hand side it could be the threat actor's own organization, and that person is transferring data from one blue circle to another one. So by just looking at this graph we could ascertain that out of all of these nodes, these two nodes are of high importance and we need to take action on these ones. Similarly, if you think about supply chain, and in the supply chain, as you know, that we transfer goods from one point to another. So just in case you think that on the right hand side of this picture, this blue circle represents the Sydney port, whereas on the other end, the other blue circle represent, let's say, Singapore port, because these ports are of very high importance. And let's say that the goods are transferred from one port to another. And let's say there is a storm in Singapore, and due to that storm, we have lost this relationship between Sydney and Singapore, and that will disrupt the whole supply chain line. And that is why, by just looking at this graph relationship and storing it in the graph database, we could automate a lot of things like redirecting the traffic or redefining the shipping routes or a lot of other things. Now, there are various other use cases you can use with these graph databases, like you can um, answer a lot of journey question. You have used Google Maps and other maps. They all work on the graph theory. Then we have some pattern matching which can be done on this basis. This is also being used a lot in today's machine learning and generative AI, because they do a lot of community detection and link prediction. Well, so this is what graph databases are, and graph theory in very simple terms is. Now looking at the AWS implementation, AWS has partnered with world's foremost graph database provider, Neo4j. Neo4j has three components in their graph databases. One is the Neo4j graph database, which is the world's leading graph database, and then we have Neo4j graph data science, which is a collection of 50 plus algorithms that operate on graphs. Then we have Neo4j Bloom, which is a BI or business intelligence tool designed specifically for understanding graphs. Anyway, so that is what Neo4j is. Now, in AWS, we can use the following architecture pattern to implement the graph database. If you look at this diagram, you will see that on the very right hand side, we have Neo4j graph database and its component. And then we have this Apache Kafka, which is managed by AWS. It's a managed service. This Apache Kafka is connecting with this graph database through Neo4j Kafka connector. So once we have connected this graph database with Apache Kafka in AWS, then we can define further connectors if we want to stream data to another connectors from this graph database, and also back and forth. So for example, if you want to use S3, you have S3 connector for Aurora, which is AWS's managed Postgres and MySQL database, a serverless offering. You can also connect it through this Aurora connector, and then we have Kinesis for the streaming data within AWS. So this is one very common pattern you will find at many places, and very simple to implement, by the way. And then another emerging area in the graph technology is the use of this graph data with tabular machine learning techniques. And then you can use a lot of stuff there too with AWS SageMaker. And I believe there is also a connector for it, which you can do through Python JDS API. And I might do another video on it, but I still need to look into it a bit more detail. So you can see that graph databases are quite nice to implement, and if your use case matches with this requirement, I would highly suggest that you play around with it and do a POC, and especially if you're heavy on supply chain or anti-money laundering or any fraud detection. I hope that this was useful. If you have any feedback, please put it in the comment section. Thank you very much.